Hello everyone, and welcome to the implementation of a hash table lecture. In this lecture, we will be implementing our own hash table to complete our understanding of hash tables and hash functions. Make sure to review the video lecture before this to fully understand this implementation. Also, keep in mind that Python already has a built-in dictionary object that serves as a hash table. You will never actually need to implement your own hash table in Python. So, let's talk about map. The idea of a dictionary used as a hash table to get and retrieve items using keys is often referred to as mapping. In our implementation, we will have the following methods. So we'll have our hash table class, and that's going to create a new empty map. It returns an empty map collection. Then we'll have a put method. It'll add a new key value pair to the map, just like a default Python dictionary. If the key is already in the map, then it replaces the old value with the new value. We'll also have a get method. Given a key, return the value stored in the map, or none otherwise. We'll also have a del, which will delete the key value pair from the map using a statement of the form delete map key. We'll also have len, which will return the number of key value pairs stored, and we'll have in, the map, and return true for a statement of the form key in map if the given key is in the map, false otherwise. And we'll explain that one a little more in detail when we actually get to it. So you have your Jupyter Notebook here. All the code that we're going to be going over is available for you here, called class hash table, and you can check it out yourself. Note, it's a lot of code, but we're going to go through it and live code it out right now. So let's go ahead and get started. All right, I started a new Jupyter Notebook, and I'm going to go ahead and create class hash table, and it's going to be an object. And let's start by initializing some attributes. So I'm going to say def underscore underscore init underscore underscore pass in self. And the only thing I'm going to pass in for an attribute that we declare at first is just the size. I'll say self.size equals size. And then I'll create another attribute called slots. In this case, we're just going to have them be equal to none times self.size, where none is essentially an item or a list with an empty item. So let me just show you real quick what I mean by that. So this is a list with a none item. So when we multiply it by self.size, imagine we said self.size was going to be 4, then it's going to give you a list with 4 nones in it. So that should look really familiar from the previous lecture. Remember that initial hash table we just had as a list of nones. And then we'll say self.data is equal to none multiplied by self.size. Okay, first method we're going to work on is put. And put is going to take in self, so we know what we're referencing, and then key and the data. So note for right now, we're only going to use integer keys just for ease of use of the hash function. All right, so first thing we're going to do is just get the hash value. So I'll say hash value is equal to self.hash function, which is going to take in key and then the length self.slots. So we actually haven't developed the hash function yet, but I'll go ahead and mark it off right now. Hash function, and it's going to say self, key, and size. Right now we'll just have it as pass, but this is essentially going to be the actual hash function. So we'll get to that once we're done putting in the put method, but this is essentially just going to be the remainder method, that very first hash function we saw. Okay. So, moving along, what we're going to do is, after we get our hash value, meaning we insert the key, the size, we'll get a hash value back. Then we'll check if the slot's empty. So, if self.slots at the hash value is equal to none, then we know it's empty, so we can say self.slots hash value is equal to the key and then self.data at the hash value is equal to that data we wanted to input here. All right, so that's the most basic situation you have where it's already none, it's empty, and your hash function lined up with an empty slot, so you fill in the key and the data. Let's go ahead and actually fill out this hash function now. We'll have it be the remainder method. So that means it's just going to return the key mod size. All right. Something to begin to note, as we've discussed before, if we have a collision case here where the hash value does not equal none, we'll have to take that into account. In this case, we'll need to basically create a rehash, so finding next possible positions. For that case, let's go ahead and create a method called rehash. It'll take in the old hash value, the size of the array, and it's going to find the next possible position by just saying return the old hash plus 1 modded by the size. So this is essentially just moving along, trying to find the next empty slot. So now that we have rehash done, we can continue to fill out our put method. So if the slot is empty, we fill it in with our key and data. Else, if that's not the case, so if the key already exists, we'll just replace the old value. So we can say if self.slots hash value is already equal to the key, meaning it's already in there, then we'll just say self.data at the hash value is equal to data. All right. So otherwise, what we're going to do is try to find the next available slot. So I'm going to say else, say next slot equals self.rehash hash value with the length of self.slots. So that matches up to what our rehash function over here, this method, was taking. So then what we're going to do is try to get to the next slot. So we'll say while self.slots, in this case we'll just call it next slot, that variable we just made, is not equal to none, and self.slots of the next slot does not actually equal the key. What we can do is just say that the next slot is equal to self.rehash, take in the next slot, and the length of the current slots, which is self.slots. Okay, so that's to get the next slot, and then we'll set the new key if none. So that means if self.slots, so that list that we're keeping track of slots, next slot is equal to none, then we just replace the value. So we'll say self.slots next slot equals key, and then self.data at the next slot is equal to data. Otherwise, we just replace the old value. We'll say else self.data next slot is equal to data. All right, let's go ahead and zoom out a bit, make sure we fully understand what's going on, because that was quite a bit of information and quite a bit of coding. So here we have right now our entire push function, and this is supposed to be on a new line right here. Okay, let's go ahead and just rerun over what's going on and make sure it compares correctly to what we have here in our official Jupyter notebook. So first thing we're doing is just initializing our hash table. We put in a size, and then we create slots and data. These are just two arrays of none with self.size, and we're using just a Python list as we showed earlier. Then we have our put method. That's going to put in a piece of data to the correct key. So where do we actually put this data? We use the hash value, which we got from the hash function. In this case, for the hash function, we just use the key and the length of self.slots, the actual slots we specified earlier, because we're using the remainder method over here. So after that, we just say if a slot is empty right here, so if self.slots hash value equals none, meaning it's empty, we just fill in the key and the data itself. Otherwise, if the key already exists, we go ahead and replace the old value. And then in that case, otherwise, meaning it doesn't exist, we actually have to find the next available slot. Meaning we have to say next slot equals self.rehash with that hash value. We get to the next slot over here, so we continually go while, and then we set the new key if none. So this is us setting the new key. Otherwise, we just replace the old value. Okay, so we found out that if we needed to use a rehash to find the next possible position, we just continue along taking the old hash function, adding 1, and then again just doing a simple remainder method. Let's now focus on getting items given a key. I'll go ahead and zoom in for this while we focus on the get method. So I'll say def get, and in this case it's just going to take in a key, just like we would for a normal dictionary. And it's going to return items, basically get items, which are our data, by taking in a key and returning the data that's matched up with that key. We're going to set up a couple variables for our search. We're going to say start slot is equal to self.hash function, which takes in the key and then the length of self.slots. We'll start off with data being none. At the end, we'll actually return data. We'll have stop equals false, just a boolean to tell us when to stop. We'll say found is equal to false. And we'll set a position marker called just equal to start slot. Okay, so right now we have start slot, and this is just telling us what slot do we start off on in our search based off the hash function. And because of our rehash method where we're adding, if it's not a hit at the hash function, what we can end up doing is just continuing on until we actually find it. So until we discern that it's not empty or found and haven't stopped yet, meaning while self.slots at that position, which is the start slot, does not equal none, and not found, meaning our Boolean variable that data hasn't been found, and not stop, meaning we haven't stopped yet, then we'll just do a check. We'll say if self.slots at that position is equal to the key, then we found it. So we can say found is equal to true, and we just set the data equal to that value, which is self.data position. Else, we'll say position equals self.rehash at the position, length of self.slots, and we'll do an additional check here. We'll say if position is equal to start slot, then we know to stop. We just say stop equals true. And then finally, we just return the data. Let's go ahead and zoom out and make sure we break this down completely. So we're trying to get a value or some data based off its key. So we set up our variables for our search. the slot we're going to start in, the data, which is none right now, whether or not we've stopped, whether or not we've found it, and the position starts off at start slot. And essentially we keep going until we discern that it's not empty or found, haven't stopped yet. So while the self.slots at that index of position does not equal none, and I need to change this to an actual keyword, none, and not found and not stop, then if self.slots position equals to key, then found equals true, and we just go ahead and return that data. Otherwise, we have to use rehash to continue going. All right, let's go ahead and add two more methods. And these are going to be def underscore get item. And these are just special methods for use with Python indexing. Self key. And we're just going to return self.get key. And the other thing we're going to do is say def set item underscore self key data. And in this case, we're just going to put it. We'll say self.put key data. And what this allows us to do, these are just special methods in Python that allow you to use that bracket notation. All right, so we wrote quite a bit of code here. I mean, it's a lot of code, but we also just basically create our own hash table using lists as our base. Let's go ahead and make sure it worked out. And I won't be surprised if we get an error, but hopefully we don't. Let's see if we were able to implement it correctly. So I'll make my hash table. I'll give it a size of 5. And let's go ahead and put on our first key. So I'll say h of 1 is equal to 1. Then we'll say h of 2 is equal to 2. And let's say h of 3 is equal to 3, the string 3. And let's zoom in on that since we're not coding a whole lot of stuff out anymore. So we create our hash table, assign some keys and some data. Let's see if we can actually retrieve it. All right, so it looks like that's working out. So 1, 2, and let's check finally 3. Looks like that's all working out. So even though this is a rudimentary implementation, we can play around with it by implementing different hash functions. So what I would recommend to you is to implement different hash functions. Meaning if you're able to take this existing code and mess around with hash function and rehash to try to implement the other hash functions we talked about throughout this lecture that weren't just remainder methods. Remember we had those middle numbers and also those square methods, as well as some ordinal value methods. Go ahead and try those out and play around with it. That way you can really build your understanding of hash tables and hash functions. Again, realistically, you're probably not going to be making your own hash table objects and classes because you already have things such as Python dictionaries, or in other languages you already have hash tables that you don't need to build out yourself. Okay, again, you have the Jupyter Notebook available to you. It has all the code so you can copy along, paste it, read it at your own pace, since I know we went through quite a bit. And just to note, it also has comments everywhere explaining every code block for you. So really go over this code slowly, make sure you understand it, and have fun with it. Mess around, make your own hash functions, and check it out. Okay, so that's it for the hash table implementation. I know it was a lot, so make sure you take your time and go over the Jupyter Notebooks that are available to you. And in the next lecture, we're going to begin to discuss sorting algorithms. All right, thanks everyone, and I'll see you at the next lecture.